we're going to talk about dividing with decimals. So something like 18.94 divided by 2.3. Now, I don't want you to think about what that exactly is. Don't try to figure it out. It's okay. Leave your calculators aside. It's okay. We're not actually ever going to talk about the real answer here, and that's okay. I just want us thinking about what it means to divide by decimals. All right? So the first question I want to ask, and I'm going to ask it in two ways. So I'm going to ask it kind of directly, like I have asked you all many questions before. But because dividing with decimals is kind of complex, I want to elaborate on what I mean. So what quotient would be too much? So I want you to figure out something that, like, yeah, that's too much. That answer is too big. What I mean by that is how many 2.3s would be more than 18.94? All right, so I want you to think about that for about 10 seconds on your own. Right, think about, like, I got 2.3 and another 2.3 and another 2.3. I got a bunch of 2.3s. What's a kind of friendly number that you know that would be too much? All right, share in your groups. Share in your groups what number and how do you know?
10. 10. 10 is friendly. Because that'd be 20.
10 2.3s would be 20.
Oh, that'd be 23.
Or you could say.
But not over 20.
All right, what'd y'all say? 10. Yeah, I heard really quickly 10. All right, and because 10 2.3s would be 23, right? We can just scale that up. 2.3 times 10 would be 23. 23 is more than 18.94. So 23 is too much. My quotient's going to be less than 10. All right, next question, you probably guessed. How much is not enough? So something you're confident that more would fit, right? And don't say 1. 1 is not enough, all right? But I want something bigger than 1. What is something that, you can think of it kind of easily, but you're also pretty sure that it's going to be more. Like, I could still fit more. Talk in your groups. How much is not enough? How do you know? All right, so I want to document our conversation. I should have started this earlier. So we know, let's see, 18.94 divided by 2.3. We said 2.3 times 10 was 23, so that's too much. All right, let me hear some of your answers for not enough. What's something that you're confident is not enough? 7. Did I hear any other numbers? 9. Anyone say anything else? 9. Anything else? 5. All right.
About that being half of that. So when she initially said 5, I thought, well, that's way too low. But then the thought of
Okay.
23 and knowing half is going to be around 10 or
Okay.
11.
All right, so I want to talk about all three of those numbers, if that's okay. We'll work our way up. So 5, how much would 5 2.3s be? Yeah, 11 and a half. 11.5, because we know 5 is half of 10. So 11 and a half is half of 23. I also heard 7. Kevin, how did you think about 7?
Because I did 2.3 plus 2.3, which is 4.6, and I added that to my 11 and a half.
Oh, so you figured out 11 and a half first,
Yeah.
and then you just added you just added it to, well, I'm going to add 2.3 times 2 on here. You knew that was 4.6, so you just added those two together to get, what is that, 16.1?
Yeah.
All right, so I'm going to stop there, if that's okay. I'm going to stop there. I'm going to leave a little space. So it's going to have to be between 7 and 10. Do y'all agree? It's going to have, because this is not enough. And the 10 is too much. All right, so last question. What might be close? And I want you to use what you already know. So that's why I wanted to write it down. That's what we already know. I want you to use what we already know to talk in your groups. Pick a number that might be pretty close. You don't have to figure out how close, but pick a number that's pretty close. So will it be closer to 7 or closer to 10?
10. Closer to 10.
Why will it be closer to 10?
We got it down to 9.
Got it down to 9?
Because 9 groups of 2 would be 18, and 9 groups of 0.3 would be 0.27.
Oh.
And it can't be 10, so it's between 9 and 10. Half of it. I
So
think
you
it'd
figured
be too
out that
big.
9 was still
A little
not
bit.
enough.
Yeah.
Right.
Yeah.
How close was 9?
Close.
Pretty close.
Closer than 10?
Yeah, I think it's closer to 9.
Yes.
Because
like
half, between half.
Okay.
would be too much.
All right. So let me hear some of y'all's estimates. What do y'all think?
I think 8.
8.
Right.
8. I heard a 9 point something over here. They actually figured out 9 as well, and 9 wasn't enough, but it was really close. And so maybe just a little bit more.
Okay, we might be wrong.
I didn't check your math. I trusted you. I'm sorry.
Puts you at 20.6.
Yeah,
Nine's too much.
Yeah, you add
18 plus, yeah, plus 2.7. Yeah, that'd be 20.7. Yeah, but 20.7 is closer than 10. So yeah, so 8 point something. 8 point something feel good? All right, 8 point something. All right, so we're going to go into our next task now. This would be consecutive. So like I would do that task to tee up this task. So this would be consecutive. So in these envelopes, you're going to see a couple different kinds of cards. There are some cards that have a bunch of expressions on them. And then there's also some cards that have headers. They look like this. I want you to take the headers, flip them upside down, don't look at them, set them to the side. We're not going to use these headers right now.
I got a question for you.
10,
So that
15.
first activity we just did, how long would that typically take in a 5th grade class?
Pretty similar to what we just did, I think. I would move it along. I wouldn't let it drag. All right, so again, take those headers, put the headers away, ignore them, don't look at them, don't read them. With kids, I would not pass them out. Y'all are adults, so I'm trying to be efficient, and so I went ahead and gave them to you. So put those away. So here's your first set of instructions. I want you to create categories based on whatever you notice. I'm not giving you categories. I'm not giving you headers. You sort them based on whatever you notice. So what categories are starting to emerge for y'all?
Yes, you people that are moving them. What categories are
I
starting
think
to
there were
emerge?
categories.
In tens and hundreds is what it looked like.
The
That's why I was.
The dividends.
The whole
Okay.
dividends.
Oh, but yeah,
Yes.
this one's
So you've
throwing-
got dividends
this
more
one's
than
throwing us
100, dividends less than 100. Okay. Why is that one by itself?
Well, just looking. We've got,
Oh, the divisor's 3 digits.
yes, sir.
Okay. What's different about that one?
Less than one.
Oh, divisor's less than 1.
So maybe an outlier.
I want you to grab some sticky notes and label your categories. I want to be able to walk around and see what your categories are real quickly.
All right, when friendly numbers is 1,
This is the only one that the decimal place would move 2 places.
and I'm separating these as well.
He's saying, because that.
So what do you want the first category name to be?
So that could actually be sorted out.
Easy to estimate.
Friendly divisors.
So these. 3-digit pull number. So this one could actually be on there.
These are friendly numbers. These are longer numbers. They're not necessarily bigger, they're just longer.
More digits.
Right.
These would be 2 digits.
So would you want to put these back here? Because these are just 2-digit whole numbers.
Quotient will be larger than the divisor, this dividend.
What'd you say?
Well, this is only one by itself. I don't know if we want to.
Yeah.
There's 2 things. One, this one has, you move the decimal 2 places, but also the quotient would be larger than the dividend because you're dividing it by less than 1. And that's the only one that's like that.
We know what we meant by that. Right, because that's less than 1.
15
And then what do you want to label this? Like,
These technically
they all have.
4 digit. Does that make them?
To me, it's more the divisor that you look at because that's where you know, you start there to know, do I need to move my decimal?
Yeah.
What's on the outside and move it, what's on the inside. And again, this is the only one that you'd have to move it twice on the inside.
Oh, I was reading.
How would you categorize it?
Where is this part
We're
of this?
categorizing.
So which other ones
What are the divisions?
Okay.
So Lisa likes it.
We're just
These are friendly
We're
numbers.
making categories.
If we're estimating, I would say this is friendly, this is 3.
This is very friendly.
They're going into
And I'm separating these as
They're 2-digit with a 2
He's
or
saying because
1.
that one has nothing as a whole number.
Oh.
So that could actually be sorted out.
That one could be by itself,
Yeah.
because half of that.
Got it.
So 3-digit, correct? We sorted these.
3-digit whole
Well,
numbers.
there you've got one that's a 2, but then that one doesn't have a decimal.
So this one,
Your divisor is a
so this one could actually be on its
by
own.
itself too, maybe.
Yeah.
2-digit?
Okay, so I'm seeing some thinking around dividends and some around
So would you wanna put
divisors.
these
Yeah.
Is
back
that-
here?
Okay.
Because these are just 2-digit whole numbers.
And those are all 2-digit whole numbers as well. Those are,
Ah. Okay.
Now we have 2-digit divided by
And then you might
no
want to,
holes. 3-digit
I don't know if you want them in order.
holes only divided
I'm
by.
anal when it comes to that. I'm looking by the divisors.
Going in order by divisor.
Yeah.
Okay.
I think you could get a better estimate that way.
Yeah.
15 more seconds.
3-digit divided by
And then
2-digit.
switch
15 more
those.
seconds.
That,
And this one we have 2-digit divided by, 2-digit whole divided by,
Just a divided by.
no, not that one, right? Because it's 0?
That one's by itself.
yeah.
Oh, I was
How would you,
reading.
no, sorry.
how would you categorize it?
2-digit whole divided by no holes.
By a number less than 1.
Right.
Okay.
Less than
Okay.
one.
Yeah, all right.
Because trying to keep the verbiage what they're used to hearing.
Right, right.
All right, back together. Don't move anything. We're not done. We're not done. Like taking off the teacher hat, you can take off your student hats. So I don't do this all the time with open sorts, but something I've started doing recently with open sorts, if I have students make headers, I will sometimes ask students to trade headers. So instead of going to like you have headers, I'm going to close this sort for you. But a fun thing that I've started doing in the past couple of months is trade headers as the first layer of closed sorts. If I see like, oh, everybody's seeing kind of some cool things, but people are seeing different cool things, that can be a neat way to increase the collaboration, extend the thinking a little bit. We're not going to do that right now, but I want to throw that out there. That's a little tweak on open sorts that I've been exploring lately. All right, so I want you to grab the headers that I told you to ignore. Pretend that I passed those headers out. So you've got 4 headers. These are going to be your categories based on the quotients. Now, let me be really clear. I do not want you to actually divide these numbers and find real answers. The headers are open enough that I want you to kind of estimate. Think about how many of those divisors might it take to get to that dividend. All right, use what we talked about earlier. The conversation around 10 might be kind of helpful. The conversation around thinking of other numbers to get close might be helpful. So I want you to do some estimating to place those cards into those 4 categories. It won't work out evenly, by the way. So don't think you're wrong if you have a different number of cards in each set. Some might have 2, some might have 4.
I'm thinking the 1, like less than 10.
So 29 divided by 2. Yeah.
What makes it easy? How are you?
Tangled up.
It's probably
Stick it in the
40-ish,
pocket instead of the clip.
less than 40.
Bigger than 4. Bigger than 30.
50. What's the other number?
50 and 2, basically. So 25.
Yeah. Less than
3 and
10.
18.
Here we go.
Let me ask you this. So I know that's not how you figured it out, but what would 10, because that's the biggest, what would 10 2.6s be?
26.
It's definitely gotta be less than 10.
Okay.
So the next one too.
How'd you know that?
Because it'd be 33.
Oh, it'd be 33.
I didn't round the 1.8 to 2.
Yeah. About 50.
Easy
Yep,
as possible
yep.
for me.
So 800.
More than 30, more than 30.
It's so close.
This would be
So
30,
close. I
or
wish I
less
would've
than
been
30.
20 and 30.
Yeah. Is that one? That one's
This one
So I just
143 divided by 10
would be
would be 14.
So that would
Maybe.
be between 10 and 20.
Are there any more that are kind of standing out to you like that? That maybe at first glance
Okay, so it's definitely got to be less than
felt
10.
pretty good.
Okay.
Where are those like weird ones that were off by themselves in round one?
the dividing by
Yeah.
0 by half.
Because half of
and
14 would be
is
7.
7. Yeah. But it's a little bit more than
And
17,
that
but a
was
little
like
bit more than half.
36 divided by 6, that next one.
Well, kind of using your strategy of multiplying the divisor by 10, isn't that what you said you were doing?
So for instance, I was going like 2 times 10
Would make
get
that
20.
26.
And so then I knew that it would be
Okay.
between 1 and 10 because I already got, or yeah, 2. I'm sorry.
Oh, you're good. Yeah, yeah. So like 2.6 times 10, 26.
Yeah.
So you can't get to 10. It's going to be less than 10. Talk to me about this guy.
Well,
0.51 times 10.
So I divided 14 divided by 1, and I
Okay.
got 14. So then I just did half of that because of
7.
0.5.
Yeah.
Oh, okay.
And I
So we
just
have a
did
number less than 1 here, right?
So it actually should be, wouldn't it be here?
Between 20 and 30? The quotient?
Because would it be double?
Instead of halving, because it's a decimal.
Because it's less than 1.
Yeah,
I almost feel like a rule emerging in it. Yeah, well, I was kind of using your strategy of the times 10, 0.51 times 10, 5.1. And then can I do that 10 more times and still be less than 14.49? 5.1, 5.1.
He said it the first time. I was like, yeah, you're right.
Yeah, it kind of it gets tricky on
Because,
there.
yeah, when you divide
Right.
by half, you're multiplying by
Right.
2.
Yeah.
Doubling instead of
Yeah.
halving.
Yeah.
Yeah,
Doubling instead.
yeah, and our brains kind of get used to,
Yeah.
we're dealing with
I think about
whole
it
number,
whenever
whole number,
you're
whole number,
dividing
right?
by
Yeah,
fractions, you're really doing the inverse.
Yes.
So
yeah, that one's fun.
Okay, so I'm seeing a bit of a mixture of, like some of them, I see a lot of groups having this conversation. Like, well, I know 10 would be this much, so I know 20 would be this much. And then there are some where like double it and then triple it, it gets a little unfriendly. And so some groups are just kind of rounding the numbers and trying to find friendlier numbers to divide. I like both of those strategies. Everyone has this card except y'all. I stole yours. 14.49, 14 and 49 hundredths, if you're mad when I say point, and 0 and 51 hundredths. So this card is a little different than some of the others. In fact, when I had y'all sort them at first on your own, a couple groups put this one by itself. A group that put it by itself, what did you label that category?
3-digit holes, 2-digit holes. No, that wasn't right.
We did a 2-digit whole
Divided
divided by a number.
Ooh, so I heard a couple things. I heard divisor less than 1. I also heard quotient would be greater than the dividend. That's interesting. Here's what I want y'all to look for. I want you to see if that really is unique about this. So take a second, look at all of your cards, and I want you to see, like, is that true? Are the rest of them, the quotient smaller than the dividend? Is this really the only one where the quotient wound up being larger than the dividend? I want to test this a little further. I want to test that idea a little further because one example isn't really enough to say, hey, generally speaking, if this happens, this is going to happen. So I gave y'all each 3 more expressions that also have divisors less than 1. So whatever strategies you were using to estimate earlier, continue to use those strategies. I want you to place these into those categories as well.
That's where I would put it. 16. And then that divided by half, if that's times 2, that's also going to go in the middle.
If I have 9 tortillas and I divide each tortilla in half, I'm going to end up with 18 pieces.
Right,
Bigger
so-
than the dividend.
that one's, I look at it so much different. I think it's, but it's not in 5th grade.
I want to hear new
45.
This is not.
I taught 5th grade for like 22
Yeah,
years.
this
These
is
teams are not now
this is
for-
like 16 times 10 over 9. Keep, change, flip. Which
multiply
they
by
wouldn't know.
reciprocal.
Yeah.
And
That
they
one's
learn that with
160.
fractions.
So like probably your thought process too is this would be divided by fifths.
This
So
would be-
45.6 divided into fifths because it's 0.2.
Yeah.
So if I said into 5, that would be between 1 and 10. So 45 divided by 5 is about 9, so it's 9 point something.
Way over, and we're not even close to 45.
Times 5.
You lost me.
18
Yeah, 10 times 0.5
would be 5.
would be 5. So 20, I gotcha, would be double
Would be
that.
roughly 18. It's doubling that 9, right?
Same thing with the next one.
Right.
Times 2, that's also going to give you
Yeah. Be closer to. That's closer to
It's closer to
whole.
1. Yeah.
So that'd be 16. Which was the other one? This one?
That one, it's closer to 0. It's still over 0.
So 10 groups would be 2 whole.
No.
20 groups would be 4 whole. 30 groups would be 60.
Just 6.
6.
Yeah.
I don't teach decimals. I'm
Yeah.
just, I don't know this.
Yeah, so if 2 groups, I'm sorry, if 20 groups is 4, what would 40 groups, like if we doubled again?
8.
8. 80 groups would be
16.
16. Oh, we're way over, and we're not even close to 45 yet. Yeah.
All right, so does the pattern hold up? I see some head nods. The pattern seems to hold up? Okay. All right, so if y'all want, the 3 separate ones that I gave you, don't put those in the envelopes, but put everything else back in the envelopes if you're good. The other 3, you can just put that paper clip back on them. I'll pick those up separately. I know that 5th graders cannot use calculators on the assessment, but something that I would actually probably do as the next step, I didn't do it with y'all because y'all already know this generalization. 5th grade is figuring out this generalization for the first time. If I'm doing something like this, I would actually give them calculators and say, double check it. Like, plug it in on the calculator. Did it really get bigger? Right? Because some of those were really close, like dividing by 0.9. It might be hard to estimate that one because it gets really close because 0.9 is not much smaller than 1. So I would give them calculators because the point isn't getting the division in that last step. The point is developing that generalization. So I'd give them calculators, have them plug it in. Does it really work? And then once they have calculators, I might give them a few more and keep checking, and they feel cool because they're 5th graders using a calculator. And we would figure out this seems to happen. When I divide by something less than 1, my quotient gets bigger. As I'm saying that out loud, I also realize I need to be really careful because negatives are also less than 1. And we're not dealing with negatives yet, and that kind of, I don't want to overgeneralize as well. So I would get to that clarification, and we divide by something between 0 and 1, our quotient actually gets bigger than what our dividend
I think
was.
that other thing, and we talked about this earlier, when I walked up and I saw the number is larger, like the difference between is the number larger or is it a longer, like more digits? So a lot of kids have a misconception if it has more digits, it's bigger. If I'm answering that question about it being larger than the dividend, so.
It doesn't have greater value.
Yeah, and all I might do, right, if I notice a student his wrote like larger and I can tell actually what they meant is there's more digits, I'm just going to tweak like, hey, is this number really, like there's 4 digits, is this really larger than 200 even though 200 only has 3 digits? I'd make that tweak, we'd change the label, and we'd move on. So, all right. So another thing we've talked about, so I want to show you real quick that I think is important following engaging tasks like that, is I also want to help students experience like what's it going to look like on FAST, right? Let's turn that engaging conversation into success on a FAST type item. So I took a screenshot of this question. It came out of a curriculum. I won't name the curriculum. I think it was Big Ideas. I can't remember. It was one I had access to. Yeah, Big Ideas people. You go, yeah, that's Big Ideas. I just copy and pasted that into my chat, And I've had ChatGPT make me a lot of ETIC type items before, so and it can use all my previous conversations. So I just said, turn this into an ETIC. A couple iterations later, I had this. And so following that sort, like this could be an exit ticket or something. So take a look at this question. Imagine this was one of those ETIC items, so all those bold text, those would just be drop downs, right? So you're choosing, is it greater than, equal to, or less than? Do I plug in 5.4 or 0.9? So as a group, on one sticky note, I want you to talk about this problem and complete this sentence, complete this statement for me. 5.4 divided by 0.9 is blank 5.4 because blank is blank blank. A lot of blanks. So as a group, talk about it, complete that statement, jot it down on a sticky note.
All right, so what do we have? What's our statement?
I think it's 5.4 divided by 0.9 is less than 5.4 because 0.9 is less than 1.
I disagree.
Okay. Why?
Because if I multiply both of them by 10, I have 54 divided by 9 is 6. Well, 6 is greater than 5.4.
Well, in that sort, what did we just figure out? Like all the ones that had divisors less than 1, what happened to the dividends? Or what happened to the quotients?
They were greater
They were
than
greater
the
than the
quotient.
dividends.
Or
Okay.
dividend.
So what do you think it should be?
I think is greater than 5.4 because
9 is less than 1.
it's greater than because
0.9 is less than 1.
It's less than
5.4
I
is
got you. I see
All
what you're
right.
saying now.
All right.
So we should have 5.4 divided by 0.9 is greater than 5.4 because 0.9 is less than 1. And this is, just in my opinion, a very fast-like item. It's aligned to that benchmark. There are lots of those ETICs that are filling in blanks. A lot of times that item type is used for some of the reasoning things. This item type is used very frequently to assess that reasoning for students. Around division, especially in 5th grade, we start multiplying and dividing by fractions and decimals. That whole idea that when you multiply and divide by stuff that's less than 1, we get unexpected outcomes, that's a big idea in 5th grade. And so there are a lot of items in the bank around that. And so giving students questions like this, building off of, hey, we just generalized that idea, here's what it looks like to formally answer that. I would want to do something like that with students.
So you put that question into AI.
Yeah, and I just I took a screenshot. ChatGPT can actually read text in screenshots. So
I have a question about it too.
Yeah.
When you give the kids that part, would you write it out like that and just teach them choose one in this set of parentheses, circle one thing? Like, does anybody do this kind of practicing? Well, it would be a drop down. How do you do a drop down? That's what we were just talking about.
The way that I've done it when I have an example in my box I can show you later, or anybody that wants to see it. The way that I've done it in anytime I'm actually doing something with students is, have you seen any of the way the fast samples, when you look at the PDFs, the way that they convert ETICs to paper-based, they just put bubbles with multiple choice. And so that's how I've done it with students. It would be it would have to be spaced out a lot. It wouldn't look really good on a slide. It'd have to be spaced out a lot, and then it would be ABC, greater than, equal to, less than, AB, 5.4, 0.9. I have an example I can dig out and show y'all later if you want to see it. But I just try to make them look like the paper-based versions of the ETICs.